Okay, now let's have a look at how to graph a hyperbola. Here are two conic sections. We recognize that this is a hyperbola because two things are being squared and there is a minus sign in the middle. That is the form that a hyperbola will take. There's two different forms. Here's one of the forms where x is leading. It's the positive term. And see, y's got a negative in front of it. Or this is one form that it would take in standard form. Oh, that pen's about gone, isn't it? Okay, that's one form it would take. The other form it could take, it has two forms, is where the y is positive and the x is negative. And here's the other form it would take. All right, what does that mean? Well, what this means is when the x term is leading. Now here, it doesn't matter. We're not looking for the longer axis like we were on the ellipse. What matters here is which of these numbers is who is in front. So x is positive. What that means is this hyperbola, which has two pieces to it, will have this type of a look to it. Over here in the second example, y is positive, x is negative. That means that this type of parabola will be facing up and down. That's what that means for hyperbolas. So here we go. Let's find the center. The center is at HK. So the center will be at 2, -4. A squared is always underneath the x squared. So A is the square root of 4. It's going to be 2. B squared is always underneath the y squared term. So B is going to be the square root of 25. B is 5. Now to calculate the value of C, which is the distance from the center to the foci, C for hyperbolas is basically the Pythagorean theorem. So C squared is equal to A squared plus B squared. So C squared is equal to 4 plus 25 or 29. C is the square root of 29. And so that's going to be between 5 and 6. So C is about 5 point something. And I don't have my calculator, but it's 5 point something. That'll help me get it on the graph. So when you go to graph these guys, you always start at the center. The center's at 2, -4. So we're at 2, -4. There's our center. Now, we always go right, left, A units to find some important points. So A is 2. We're going to go left 2. We're going to go right 2. So I'm going to go over 2 more from the center. That's an important point. And then I'm going to go up and down B. B is 5. So I'm going to go up 1, 2, 3, 4, 5 from the center. It's in line with the center. And down 1, 2, 3, 4, 5. And this is where it is. So those are the important points. Now we are about to figure out which one of these important points gets the special labels of a vertices where the foci will be in line with, okay? How we decide this for hyperbola is not which one is longer, but which one is in front. So x was in front. That means my parabola will be symmetric about the x. That means this one and this one are my special vertices. So this one will get called V1 and this one is V2. Those are the important points. V1 and V2. So let's label those coordinates. If the center is at 2, -4, to get to V1 I'm going to go left 2 units. So if I go left 2 units, that's going to put me at, oh my goodness, I just realized I messed this up. I put this at -2, -4. Gosh, I'm sorry about that. Let me just fix my mistake. I'm going to make this a plus. I'm cheating a little bit and make that a negative so I don't have to redraw my whole graph. Sorry about that. -2, -4. Now my graph looks better. Okay. So I'm going to move -2, which will make V1 at -4, -4. And then if I go right 2 units off the center, this will become 0, -4. Okay. And so my parabola is going to be like, it's going to be like this. How I decide how to form my graph is with the asymptotes. So if you use the box method, see I drew this rectangle? you can use the box method. These are, oops, that doesn't really slope like that. These are the asymptotes. They're not part of the graph, but they help shape the graph. What I'm drawing now is the hyperbola itself. It will look like that. All right, so this one is V1. This is V2. Okay, now the foci are always enclosed by the graph, and they're in line with the vertices. So they're going to be here and here. I'm going to move 5 units from the center, left and right. So if I'm right here, I'm going to go left 1, 2, 3, 4, 5. There's like my F1. I'm going to move one from the center, 1, 2, 3, 4, about here for F2. The coordinates for F1 and F2, let's see. If I went to the right, C units from the center, I started at -2, and then I'm going to go plus the square root of 29. That is my x coordinate, and the y coordinate is still -4. F1, I'm going to go -2 minus the square root of 29 to move me left, and the y coordinate's -4. The only thing left to do is write the slopes of the asymptotes. Slope is rise over run. We have two. We have this asymptote and this asymptote, so it's a plus or a minus b, which is your rise, b was 5, over a, which is your run. And so that is the end of that parabola. Okay, let's look over here at this guy. We already said, okay, we've got leads with y, so that means it's going to look like that. So here's the deal. The vertices will be there, the foci will be there. That's what we know about this guy. Okay, so the center is opposite of x plus 1, so it's going to be at -1. Opposite of -1 is going to be at +1. So x is -1, y is +1, hk. The value underneath y is b squared, so b is equal to 3. The value underneath x squared is a squared, so a is 4. C squared is the Pythagorean theorem, basically, so 9 plus 16 is 25, so C is 5. That's a nice whole number for us, okay? So let's see here. Let's try to graph this guy. Start at the center, which is at -1, +1. Hopefully I did this one okay. There's our center. Now what we do is we go left, right, A, up, down, B. So we'll go left, right, A, which is 16. So we're going to go, A is 4. So we're going to go 1, 2, 3, 4. And then here is our important point. And then we're going to go left, 1, 2, 3, 4. And here's our important point. And then we're going to go up B. So we're going to go up 1, 2, 3. That's an important point. We're going to go down 1, 2, 3. That's an important point. Then if you use the box method, you can just form this little rectangle, which is an easy way to form your, I think I went a little bit high on that, your rectangle. You can go ahead and lay out the diagonals if you want, which are the asymptotes for our curve. So right now, what we've plotted so far, we've only plotted 2 points on our actual curve, and those are the vertices. The question is, which one of these are the vertices? Well, what's going to tell you that every time is for hyperbolas, who is positive. Since y was positive, this means that my hyperbola will be symmetric about a y-axis. So that means these guys right here are the vertices. What that means is this is where the foci will be in line. So I can go ahead and sort of make my hyperbola like that. The foci will be in line here. They're going to be 5 units from the center. Well, if the center's at -1, 1, -1, 1, that means I'm going to go up 5 units. So I go up, let's see, 1, 2, 3, 4, 5. There's my first one. I'm going to go down 5 units. 1, 2, 3, 4, 5. There's my second one. So F1 will have the coordinates. I'm going to label them over here. It has the same x coordinate as the center, which is at -1. But I go up c units from the center, so 1 plus 5 is 6. I go down 5 units from the center, 1 minus 5 is -4. The only thing left to do is write the slopes of the asymptotes. It's always rise over run. The rise is the b, which is 3. The run is the 4, which is 4. Those are the slopes of the asymptotes.